All right. So, hey guys, I'm going to be doing this on my Mac, so I hope everything works out okay. Because let me see, the Mac is slightly different, and I tend to accidentally hit a button that screws up my keyboard way more often on it, which kind of sucks. But anyway, this is installment 5, and this has got some pretty, um, I don't, maybe not hard, but maybe just you need to pay attention to it. So part of me was thinking about doing it in class, but honestly, having it on tape, I don't think you guys are quite using the notes. Some of you don't use the notes the way you should. Look, the topic is right here. Okay. So this is the name of the topic. When you are taking notes, maybe you want to mark the date of the notes, like trig number 5, or the title of the notes, date of the notes, whatever, and then write down these problems so that when you get them, you can refer back to your example. Okay. These kind of problems that are coming up are going to be word problems with triangles. And the key to word problems is simply, again, use your trig. Okay, use your trig to figure out what relationship they're giving you. Separate the triangles, draw all the triangles that you have so you can see the picture clearly. Okay, that's really what it's about. So you have this situation here. You're going to get a lot of these where you have like a ladder against a house, or you got a pole that fell, or you got, like, I don't know, various things. Okay. A 7-foot ladder against the side of the house. How far is the bottom from the side of the house when the angle of elevation of the ladder is 67 degrees? So let's talk real quick about angle of elevation and angle of, oh God, is it depression? So look, if I have two parallel lines, so usually that's the case, what's going to happen, you'll see? I just want to show you that they exist, okay? And then this is the transversal. Okay, if you're talking about looking from the ground up, this is the angle of elevation, okay? If you're talking about, like, if this is a plane, okay? I seriously can't draw a plane. Don't make fun of me, okay? This is my sad plane, okay? Okay, that's my plane. Okay, this is the angle of, oh, I want to say depression. I don't know why I'm having a hard time remembering the word. Okay, we'll come upon it, I think. So elevation doesn't look like elevation. They're basically the same though, because they're alternate interior angles. So you don't need to worry all the time about it. Just it's important to know which one it is. And this is angle of elevation right here, 67 degrees. Well, all you need to know is this triangle right here, okay? Here's your right triangle. Of course, you have a right triangle because houses are perpendicular to the ground, which is a good thing, right? So they don't fall down. All right, we're looking for this. I'm going to call it X now instead of a question mark, and then that's 7. So what do I have? I have a hypotenuse, and then I'm looking for the adjacent. So the trig function that goes with adjacent and hypotenuse, okay, so ka TOA. Okay, adjacent and hypotenuse is cosine. So what we're going to do is write a true statement. And from there, we're going to be able to solve. So you're going to go cosine of 67 is equal to adjacent over hypotenuse. Just tell yourself what it is. Adjacent over hypotenuse, which is x over 7. You're going to multiply both sides by 7, because we got to get rid of the denominator, right? We want to get rid of the denominator. It's dividing the x. We need to, okay? And then that's what you plug into your calculator. X is equal to 7 times cosine 67. So if we have, oh, I don't have a calculator open here. Not sure why I don't. Let's try this. Calculator. Here we go. Google has a nice one. Okay, so we're going to go 7 times cosine of 67. So you just put it in, 7 times cosine of 67. Boom. What? Oh, you guys, if you ever get weird stuff, it's because it's on radian. When you use this calculator, it defaults to radians, and that's a bad thing. I wish it would default to degree. Okay, so now we have to do it again. If you don't know about radians yet, and we won't be learning about them this year, but yeah, they're a different way of measuring an angle. So 2.7 is what we got here. So round your answer to the nearest tenth, and I did. 2.7. Now, if we were doing this not on Alex, I would be so picky about you putting feet. Okay, 2.7 feet. Basically, it's going to be all the same. It's going to be about, oh my God, I'm stuck in my cords here. Okay, it's going to be about drawing your triangle, making sure you've named the sides and used the correct trig function. I'm going to enlarge this with just my pencil so that you see it's pretty easy to copy these down. 65, x, 85. All right. So now name the sides. If you want to not get confused, name it. You've got opposite and you've got hypotenuse. So which one is that one? It's sine. Opposite and hypotenuse is sine. Okay, so now you're going to write a true statement. Sine of 65 is equal to x over 85. I'm not going to actually figure this out because it's the exact same as the last one. Okay, plug this into your calculator and you are going to be good to go. Okay, and again, so you can see, this is angle of elevation. See, angle of elevation. I'm sorry, I didn't even read it. Apologize. You guys, if I do that, you can always stop and just read it. But this is the angle of elevation. See, it's from the ground up. So that's why we're doing that. Okay, next. Okay, so sometimes you get these with two triangles and you might be intimidated by it, but don't be. Just look at the two triangles and take them out if you have to. Okay, so it says a surveyor, that's a person who measures things and, builds roads and stuff like that. A surveyor wants to know the length of a tunnel built. I'm bothered because I'm like, no, a surveyor doesn't actually build the roads, but they give the measurements, okay, for the people that do need to design it, okay? A surveyor wants to know the length of a tunnel built through a mountain. So there's the tunnel. See, a car would be going in here. Don't laugh at my car. Okay, there's my car. Car's going in the tunnel, okay? According to her equipment, she is located 243 meters from one entrance. Okay, so here's where she is right now. Okay, at an angle of 47 to the perpendicular. Okay, so that's 47 right here. Okay, they're just explaining the picture. Also, according to her equipment, she is 186 meters from the other entrance at an angle of 27. Okay, so look, you've got two right triangles, you've got two hypotenuses. Okay, you've got two of them. All right, and what are we looking for? Based on these measurements, find the length of the entire tunnel. So we need to find this piece, but we also need to find that piece. Okay, so I'm going to call this piece X and this is Y, and the whole tunnel is going to be when we add them together, right? So if you want to take it apart, you could always do that. You can always take apart the first triangle. If it bothers you to see it like this, it's 243, this is the hypotenuse. Okay, and this is the one we want. All right, and this is 47. So remember, from here, this is where you are standing. Okay, that's not where she is, but this is where you are standing and looking. What sides did they give you? You can always find this angle too if you wanted to, but I'm just using the one they gave us. So this side is the opposite, and this side is the hypotenuse. Opposite and hypotenuse is sine. So, okay, so I'm going to write a statement. Sine of 47, because that's what I have, and these two things are stuck together. You may not separate that 47 from the word sine. It's not sin, by the way, it's sine. Okay, these two are stuck together because the sine means take the sine of 47, okay, equals x over 243. And then to solve for x, you just multiply by 243 on both sides. Okay, I want to show you something real quick because I was noticing People are still struggling with sometimes these ratios or these proportions. I'm going to show you a couple quick tricks just in case you want to learn them. Okay, sine 47 is over 1. If you guys want to put sine 47 over 1, you are welcome to cross multiply because look, it's a proportion. And then you get 243 times sine of 47, right, is equal to x. Okay, the other thing I wanted to show you, and you could just write this down in your notes. I don't know if you guys remember this, but A over B, if A over B equals C over D, okay? Did you guys know you could just flip them? B over A equals D over C. Do you see what I just did? In other words, if 8 divided by 2, which is 4, is equal to 4 over 1. See it? Look at this. I can actually go, well, that means 2 over 8 is equal to 1 over 4. And I can flip it. That would come in really handy sometimes if the variable's on the denominator and you don't feel like doing a lot of work. Okay. But that's just an aside. I just wanted to show you in case you got that down. All right. So basically, that's going to be your x. I'm not going to multiply it out. Yeah, that would be your x. And then you would need to do the same for the y. Okay, so I'm just going to draw this real quick. Okay, you have 27. And again, it's sine again. It's opposite is y. It's what we want. And we have the hypotenuse, which is 186. So you're going to write a statement. Again, sine 27 is equal to y over 186. Multiply both sides by 186. And there you go. That's y. Y is equal to 186 times sine 27. So then you would put those into your calculator, add them together, and that would be your answer. I'm not trying to just make this, I'm just trying to make, okay, blah, 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 blah. Spaka, can you talk? I don't want to extend the notes and make them harder because I believe you guys have all done enough of these problems where you don't have to worry about learning how to plug it into the calculator. Okay, now look, here's another problem. Really what you need to do is separate these triangles and it will help you, I promise. It's telling you this lighthouse is sitting on the edge of a cliff, okay? Here's the cliff. Okay, a ship at sea that isn't stuck in the Suez Canal, okay, is 980 meters from the base of the cliff. So this is where the ship is, okay? This is all ocean in here, okay? The angle of elevation from sea level to the base of the lighthouse is 47.3 degrees. Okay, so look and see, this arc is going to be really important because that's 47.3. The bigger arc, okay, is the angle of elevation to the top. Okay, most likely they're going to want the height of the tower. Let's see. Okay, find the height of the lighthouse. That's what they want. Okay, do not round any intermediate computations. Round your answer to the nearest tenth. Okay, so what they want you to do is actually come up with a plan. So how would you do this? Okay, think about this. What we need to do is figure out this whole height, right? We can figure out the big long side. I'm going to put it the height of the large triangle, okay? The height of the large triangle, see? And then to find the lighthouse, we need to like subtract the cliff height, right? So then we're going to subtract the cliff height, which is the height of the smaller triangle. Do you see that? So we're going to go minus the height of the smaller triangle. When you are having trouble with word problems, it's often very, very, very helpful to write actual words of how you plan to do this. Now you just need to come up with what is the height of the large triangle. You could rewrite the large triangle here if it makes you nervous with like too many lines here. It's 51.3. We are looking for H, okay? So what do we have? We have adjacent, and we're looking for opposite. Opposite over adjacent is TOA. Make sure you have SOHCAHTOA written. Make sure you have all your trig written and available for your reference. So we're going to use tangent. So we're going to write the height of the large triangle. I'm going to write it actually underneath my words because it's going to be the tangent of, actually, no, I'm not. I'm not going to do that yet. I'm going to actually figure it out. What is h? So I'm going to write this over here. I'm going to go tangent of 51.3 equals h over 980. Now, when they say they don't want you to round off any intermediate, what it means is, look, see, this is the height. Do you see it's the red height? It's equal to 980 times tangent of 51.3. That's what they want you to put into the calculator. They want you to do that to make it easier. Now let's figure out the height of the small triangle. So I'm going to copy that one here. Okay. And that one has 47.3. And we're looking for the height. And this is 980. So again, we're going to use tangent because opposite over adjacent. So we're going to go tangent of 47.3. That's how you say it. Tangent of 47.3 equals h over 980. So times 980, multiply by 980, okay, cancels. And then the green height is equal to 980 tangent 47.3. So we're going to write that. When I say 980 tangent, it means 980 times tangent of 47.3. When it's right next to it, it means multiplication, okay? And we should know that because we multiplied both sides by 980. So I could put a little dot there. This is what you're going to plug into the calculator. Okay, I'm going to go ahead and do this one. Okay, 980 times, I feel like I want to factor out the common factor. Like I could do it like this, you guys. Tan 51.3 minus tangent of 47.3. I'm not going to factor out the tan because they are attached. The word tan is attached to these numbers. I could do that. Do you see how both of them are being multiplied by 980? So I just factored it out. Okay, 980 times 51.3, 47.3. Is that right? 51.3, 47.3, yeah. Okay, so we're going to go. Oh my God, you guys, I'm so tired. What the heck? Oh God, 980. Thank you, brain, failing me. 980 times parentheses tangent of 51.3 minus tangent of 47.3. Close parentheses on the tangent. Close parentheses on the, oops, I need to put a close parentheses right there. Ooh, shoot. You guys, do you see what I did? Okay. I need to make sure I close this. See, right there. Okay. Oh, I don't like this. Because now, okay, you know what? Putting it into this calculator is making it harder because it was only going to multiply 980 by the first one. So you know what? I'm just going to put it in the way it came because this is not a calculator that I can manage as easily. What was it? 50. Oh my God. Sorry, peeps. 51.3. Okay. So tangent 51.3, close parentheses, minus 980 times tangent. It's just easier with this calculator. 47.3. See, so it tells, okay, so there we go. Boom. 161.2. All right. And that's your answer. That's what you need to do. Screw this. That would be fine if you had a different calculator. Just enter it like this when you guys get it, okay? Anyway, you would get your answer, and that was it, 161.2. That's how tall that lighthouse is, 161.2 feet. It says round to the nearest tenth. Okay, got it. All right, next. Okay, a lot of you have hit this one, and I had to tell you I haven't taught you yet, but I'm going to teach you right now. Okay, so far, we've been putting in the values of the angles. This is now a variable is on the angle, and we have to find out how to do that. So in other words, if you have like, let's just pretend we have, this is pretend, this is not this problem, okay? If you have the cosine of 30, okay? The cosine of 30 has a specific value. It is a number, okay? Well, that's all in good. That's great. But what's cool about it is sometimes if we know the value of the cosine, we can find the degree of the angle, okay? And that's what we're going to do now. There's a button on your calculator, okay? It looks like this. It's not here. Let's see if I can. No. Do we have a second? On this calculator, I don't see it. But I would think there would be a second button. I don't see it. Okay. Let's see. Let's see if I have it. If I can do trig. Just gonna see if they have one. No. I'm definitely not hitting there. Okay. On your calculator, okay, there is a button that's usually with the cosine. It'll be like cosine, and then above it, it's usually like a little cosine -1. There will be that. I don't know. I think Alex might actually have these as two separate buttons. Okay. The cosine, it looks like this. Cosine -1. The -1 is an exponent. This is the inverse. This is not cosecant or secant or anything. This is the inverse. It goes from the value, gives you, I should just put to the angle. To the angle. Like, okay, so when I was a kid, you can still find them. There's a chart. I'm going to try to find it just for the fun of it because we used to have to do this chart of sine or chart of cosine since I'm doing that. Okay, when I was a kid, this is how we had to find our angles. Let me see. I think this is going to be a unit circle. Dang it, anyhow. No, I'm sorry. I just want to have fun with this. It's just chart of cosine with angles. So in your books, they still have these where they go by 1 degree, literally like this, like where they'll just tell you, dang it. Oh, man, this is kind of sucky. Oh, here it is, right here. Okay, take a look. If your angle measure is 1 degree, that's the cosine. If your angle is 0, that's the cosine. If your angle is 2, in other words, this is how we used to have to do it. We had a chart like this and we had to look it up. So if I say the cosine of 30, it's 0.866. But what if I tell you, hey guys, the cosine of an angle is 0.866? Then you could look here and be like, oh, it's 30. Or say I said the cosine is 0.62932. Can you find that? 0.63932. So you're like, here, okay, wait, it's going down. Yeah, there it is. Okay, the angle is 51. That's how we used to have to do it because we didn't have scientific calculators. I sound really old. I'm not all that old. It's just that technology went really fast. Okay, so these are values. Look at 60. 60 is 1/2. So if I told you, hey, the cosine is 1/2, you'd be like, oh, that means the angle is 60. Okay, kind of get it? All right, so that's what you're going to be doing. Okay, you're going to be using this inverse button. That inverse button is basically like a little electronic dude going, hey, okay, there's the measurement. Let's go to the angle. Like that's what it's doing. Okay, so here we go. Okay, you are going to now, let's see, ready? I'm going to make this very algebraic as well so that hopefully, even if you're not quite getting it, like why, it'll still make sense. Okay, so look, you've got x. You name the sides. I've got adjacent and I've got hypotenuse. That is cosine. Cosine is adjacent over hypotenuse. So katoa, right? Ka. Okay. So now I'm going to write a true statement. cosine of x equals 9 over 16. That's giving me a value. 9 over 16 is a value. So check this out, you guys, just for the fun of it. Look, where's my calculator? I lost my calculator, guys. Okay, here's my calculator. Let me find it again. Calculator. Here. Okay. Look, 9 divided by 16. 9 divided by 16 is 0.5625. If I had to go look on my chart, look, 0.5625. Where is that? 0.5625, 0.5625, 0.5625. Oh man, it's between 56 and 55. Do you see it? Here's 0.55 and here's 0.57. Okay, so we'd have to like guess. We put it halfway. I'm not sure what I would do, but here, you don't have to because you have a calculator. Okay, let me do scientific. I need scientific. Dude. Give me a, no, I need a scientific. I need cosine inverse. How can I not get it? Wait, Desmos maybe? Can you do scientific calculator on Desmos? I know I've done it before. Okay, there's Desmos. Okay, take a look right here. See, sine, cosine, tangent. That's what you're using. Okay, you've already been using those, but look. Sine inverse, cosine inverse, tangent inverse. Okay, so these are going to take you from measurement of, or the value of the sine or value of the cosine to the angle. So look here. You've got cosine x is equal to, what did I say it was? 0.5 something, crap. 9 divided by 16 real quick. Let's go back here, main. 9 divided by 16 is 0.5625, okay? So you would do that. I'm going to show you this, but I'm going to show you a quicker way in just a second. 0.5625, right? Now, to undo your cosine, we don't want the cosine of x, we just want x. X is the value. So to undo cosine, you would I want to do this in a different color. You would take the inverse cosine of both sides, okay? Inverse cosine of both sides. Okay, what it does is it undoes the cosine. Just like addition and subtraction undo each other, inverse cosine and cosine basically cross each other out and you just get x. That undoes it, okay? Basically, that's gonna knock it off. And then now you need to enter this into the calculator. I highly recommend you don't actually find this fraction. I just wanted you to see that you could. I recommend you just leave it like this. Cosine inverse of 9/16. And so you're going to go to your calculator and you're going to go to functions and you're going to go cosine inverse. Well, okay, cosine inverse of 9 divided by 16. And there you go. It's 55.7. Remember, I told you it was between there, right? 55.7. It was between these two. Okay, and that's where it is. So 55.7, 55.8 actually. 55.8 degrees. All right, so when you have something that says cosine of x equals 9/16, what you really want to do is x is equal to cosine inverse of 9/16. We are literally taking the inverse cosine of both sides and undoing this cosine. This is the quick way to do it, but you have to know what you're doing. Okay, you just plug it into the calculator. All right, next, we'll try another one. Okay, here. Okay, it says, here's x again, and what sides do we have? We have opposite, name them, hypotenuse. That is sine. So write a true statement. Sine x equals 15 over 20. So to undo the sine and get rid of it, you would take the sine inverse of both sides. Okay? And that means you would do this one as well. Sine inverse. It has to go on the left. You can't do it on the right-hand side because you have to enter it first into the calculator. Okay? In other words, x is equal to sine inverse of 15 over 20. Or 3/4, but whatever. Okay, here we go. So you take your calculator and you are going to go, do I have an all clear, you guys? Clear all. Okay. You're going to go to the functions and you're going to go sine inverse of 15 divided by 20. And there you go, 48.6 if we're rounding to the nearest tenth. X equals nearest tenth, 48.6. Okay, when I have you guys solve a triangle, there's going to be, for the take-home test, this is definitely going to be one of the problems where you have to go backwards. Okay, next, there's another house problem, but this time we have an angle to find. Okay, so here we go. Again, they're just explaining there's a ladder. It leans against the side of the house. It happens to be perfectly edged here, right? Okay. The bottom of the ladder is 6 feet away. The ladder is 16 feet. And then we want to find X. Okay. So again, you can copy the triangle roughly 6, 16. And this is X. Okay. What do we have? Name the sides. We have adjacent and hypotenuse. That is cosine. Okay, so we're going to go cosine of x equals 6 over 16. To undo the cosine, we take the inverse cosine. This is the ratio. To get to the angle, you just plug this into your calculator. So we're going to go cosine inverse of 6 divided by 16. And you get 67 point, ooh, this is a good one. Look, 67.97, the 7 rounds that up to another number, which rounds up there. And when you put in your answer, you have to actually put it to the nearest tenth. So when you go in there, X is equal to 68. You can't just leave it as 68. You actually have to put 0.0. You have to get it to the nearest tenth. Okay, and that's important. All right, next. Okay. In my experience, kids don't have trouble with this, but for some reason, I feel like everybody is going to have trouble with it. I don't know why, but yet I don't really have that background to prove my feelings. Okay, 16x 33. Okay, all right. What do I have? I have adjacent and hypotenuse. This is cosine again. So it's going to go cosine of x equals 16 over 33. So again, x is going to be cosine inverse of 16 over 33. If you had tangent opposite over adjacent, you would tangent inverse. If you have sine, sine inverse. Get the idea? Okay. Now, this is the law of sines. This is something new. Notice, this is not right triangles. It's the first time we ventured out of not right out of right triangles, okay? This is called the law of sines, and it is a great law, and it's kind of fun to use, and it's actually really easy if you understand one thing. It seems to me that I usually neglect to teach because I think it's obvious, and it doesn't necessarily, and it really isn't apparently. I'm going to enlarge this. Okay, look, capital A, capital B, capital C. That is the name of the vertices. Those are the names of the vertices. Speak English, Miss Baca. Okay. The opposite side of A is little a. The opposite side of C is little c. The opposite side of B is little b. That is very important for the law of sines because the law of sines says this. A over sine A is equal to B over sine B is equal to C over sine C. And then you can flip it. Remember I was telling you about fractions and you can flip up? You can literally do it this way too. Sine A over A equals sine B over B equals sine C over C. Now you'll never have two equal signs. I just want to show you that this is the law of sines. All of these are equal. So what's going to happen in these problems? They are going to give you enough to do one proportion, either like with A or B or C or A or C, just one proportion. Okay, so let's write what they gave us. Here we go. Okay, they gave us that B is 47 degrees. So here we go. B is 47. That's the name of the angle, okay? C is 66 degrees. And A, little a, do you see it? That is 42, okay? It says solve the triangle. Solve means find all angles, find all sides, okay? You can find the third angle real quick. 180 minus 66. I guess I'll just do it one at a time. 114. Yeah, minus 47. Take away the other angle. 14 minus 7 is 7. 10 minus 4 is 6. Okay. So this is 67. Okay, look, we have all three angles now. We have one side. Okay, we want to find the other two sides. So we're going to use the law of sines, and it's kind of fun. All you do is do this. Okay, we want to find B. So I'm going to tell you which one I'm going to use. I'm going to use, first of all, I'm going to use this right here. I'm going to pull out this proportion right here. C isn't involved right now because we don't need C right now. Okay, I'm going to pull out A over sine A is equal to B over sine B. The reason why I left it with the little b on top is because that way I don't have to try to get it to the top. Like we don't want our variable on the denominator. I don't want it down here because then I have to move it to the top. I mean, I guess it would cross multiply, it's fine, but still. All right, so now you substitute. So remember, formula, substitution. Okay, I'm going to go ahead and move this up. Hang on. Okay, now we're going to do substitution. Make sure you write down this law of sine. It's part of just doing good notes. Now we're going to plug in. What is A? A is 42. What is capital A? 67. Equals B over sine B. Got it? Well, we don't want B over sine 47. We want B by itself. So we need to multiply both sides by sine 47. That cancels out, and this one multiplies here on the top. Okay? In other words, what is B? Sorry, I'm going to have to go over here. B is equal to sine 47 times 42 divided by sine 67. So I'm going to 42 times sine 47. Okay, so all clear. Sine 47, is that what that said? Sorry, guys. Back and forth, back and forth. Sine 47 times 42. It doesn't matter if I put which one first. Okay, but I do need to close my parentheses. Times 42. Okay, divided by, I can put equals. And if I put divided by, I don't know if that screws it up. Hang on a second. Answer. Wait, what? Did I accidentally do something wrong? 42 times sine 47. Okay, is, and then take that and then divide that by, wait. Oh, that's interesting. Sorry, I don't know this. Okay, let me take this. I don't know how to do this, you guys. Whatever, 30. You should just do this in your calculator. Don't use this one. You should have a calculator. Theirs will work better. Okay, 47. I don't know where all everything is apparently. 30.7, whatever, divided by, what was it? You guys could probably beat me to this, sine 67. And you should. You should be trying to beat me to these answers, okay? No, I didn't say that. Oh my God, you guys. I'm gonna go crazy. Sine 67. There we go. 33.4. Okay, 33.4. Okay, let me redo this. I think you could do this, okay? Parentheses, and then do sine 47, close parentheses, times 42. It doesn't matter the order. Just put them in parentheses. Okay, that's telling the computer to do all that first, then divide by sine of 67. Okay, and then you get 33.4. That's how you put it in the calculator. Make sure you group together the numerator. 33.4. Here we go. 33.4. B is equal to 33.4. Woo! Well, we got B. Yay! We're not done. We now have to find C. Okay? I have to erase stuff because I don't have enough room. So make sure you copy this down because you can pause it, rewind it, whatever. So now you're going to have to use a different proportion. You have now solved for B, so it doesn't matter which one. You just need to include sine C. So I'm going to put C over sine C. I'm going to use this one. I don't care. I'm going to use A because they gave us 42, just in case I screwed up. So I'm going to go back to the A. A over sine A. Okay. And then I'm going to, again, C over sine C. What is C? 66. Is equal to A 42 over sine of 67, because that's A, sine A. So basically all we're doing is plugging this in, okay? Nothing more. It's really nice, these proportions. And then cross multiply, okay? Let me go ahead and write this over here. Okay, cross multiply, you have a proportion. So I can go C, you may not want to do this actually. Maybe not cross multiply. Maybe just multiply by sine of 66. It's a little easier, honestly. You're welcome to cross multiply and then solve, but you end up dividing more. So C is equal to 42 sine 66 over sine 67. And then you would plug that into the calculator. I'm just going to, well, do I need to do it one more time? So we want to put, basically what you want to do is you want to put this in parentheses on the top, okay? So when you enter it in your calculator, okay, you want to do parentheses, okay? And then you're going to go 42 times sine 66. I hope I didn't make any mistakes. So hopefully if you guys find it, it's just 42 times sine 66. Close the parentheses on the sine. See how that did that? Then close the parentheses. Oh, wait, no, I don't want to close the parentheses on the top. I need to multiply it by, no, I don't. I just need to close it. 42 times sine 66. Yeah, that's what's on the top, right? Yeah. And divide by sine 67. Sine of 67. So these problems are very much calculator problems. 41.7. They feel very, very calculator-y, if that's a word. Calculator-y. Okay, so once you find C, okay, which we did, it's 41.7, okay, then you've solved the triangle. You've basically found every side and every angle, and that means solving a triangle. So the only time you want to use this, you guys, is when you have a triangle that isn't right. Use trig for all your right triangles. Use this for not right triangles. Okay, we're going to try another one. Consider a triangle like the one before. Okay, here we go. I'm going to do it bigger here. Okay, here's angle A, here's C, B, A, B, C. See? Opposites, always opposites. A is 76, B is 69, C is, C, little c. I was like, why would they give us that one? Is 51. Okay, so we can find angle C right away. Okay, 69 plus 76, 145. 180 minus 145 is 35 degrees. So we found it, 35 degrees. This is obviously not drawn to scale. This looks like it's the biggest angle and it's the smallest one. Okay, but these all add up to 180. So now I have all my angles, but I need A and I need B. Okay, so I'm going to, I need to do C. I'm going to find A first just because I like A. It starts the alphabet. So I'm going to go A over sine A is equal to C over sine C. Formula substitution. What's A? I don't know. I don't have A. What's C? 51. What's angle A? 76. Plug it in. What's angle C? 35. Now I need to solve for A. So I multiply both sides by the sine of 76. Cancels here. And then that's what you plug in the calculator. 51 times sine 76 divided by sine 35. Then you find A. Okay, 51 times sine 76 over sine 35. Let's do this. Okay, 51 times sine 76 divided by sine 35. I think that's right. Whoa, I did not do that right. Boom. Okay, see how I didn't close off? Boom, that's why I have to do that. Close off your parentheses. Sine 35. Okay, that's correct. 51 sine 76 divided by, yeah, that's right. And we got 86.3. Okay, so now that we've got 86.3, we now know what A is. Okay, 86.3. Now we need to find B. So you can pick either A because you have A and B. You have A and C. I usually pick the one they gave us in case I made a mistake. So B over sine B equals C over sine C. Okay, so now we're going to substitute in. We're going to get, okay, B, which is B. We don't know what that is. Sine B, sine 69, equals C, 51, over sine C, 35. Not cross multiply. Sine 69 on both sides. Sorry, guys. Can I move over a little bit? Yeah, I can. 69. Okay, wow, it really doesn't like me there. Sine 69. There. All right, these cancel, and you just get B equals. Okay, B equals. Let's go. 51 times sine 69. 51 times sine 69. And then look, I forgot to put the parentheses. So look, I can put a parentheses there, and it added it right there. Okay, I didn't need to do that. I guess it was fine. Look, see, I added it at the end, and it was like, okay. Okay, and divided by, is it sine 35? Let's see. I forgot. Sine 35. Okay, sine 35. No, I don't want it there. I want it over here. Sine 35. Boom. 83.0. Okay, again, see how the 1 doesn't round that 0 up? You have to put it. So 83.0. And there you go. 83.0. We have solved the triangle. There is more to do with this. This is problem type 1. Problem type 1 is where you find the side. Problem type 2 is when we're going to be having to undo the angles and find the angle. So problem type 2 will be when you have a triangle. I'm just going to kind of introduce it and say they only give you one angle and you need to find the others, but they give you like two sides. They might give you like 15 and 10, and you're supposed to find that one. Okay, that's where we're headed, but we're not going to do that yet. Okay, all right, that's the end of these notes.